In this video, we're going to focus on graphing trigonometric functions. We're going to graph sine, cosine, secant, cosecant, tangent, cotangent. We're going to talk about how to identify the amplitude, period, phase shift, vertical shift, and a lot of stuff that you need to know regarding this topic. But let's go ahead and begin. So let's talk about sine and cosine. You need to know that this function, y equals positive sine, looks like this. Let's talk about just a generic function. Sine starts at the center, it goes up, then it goes down, and it comes back to the center. That's positive sine. Now what about negative sine? How does the graph of negative sine x look like? For this graph, it starts at the center, just like positive sine, but instead of going up, it's going to go down first, and then it goes back to the middle, and then up. So that's the graph of negative sine. Now what about positive cosine? How does the graph look like for this function? Positive cosine doesn't start at the center. Rather, it starts at the top. Then it goes down, back to the middle, and back up. Now, if you want to, you can draw some more cycles. You can keep it going if you want. Now, can you guess how negative cosine is going to look like? How can we graph negative cosine? Whenever you put a negative sign in front of a function, it's going to reflect over the x-axis. So therefore, negative cosine, instead of starting at the top, it's going to start at the bottom. Then it's going to go up, back down, and so forth. Now you need to know the measure of one cycle. For a sine wave, this is one cycle. For a cosine wave, this is one cycle. It starts from the top, and when it gets back to the top, that's one whole cycle. What's the difference between the graphs y equals 1 sine x and also y equals, let's say, positive 2 sine x? What's the difference between these two? Go ahead and graph these two functions. Now, the first one is going to have an amplitude of 1. So it's going to vary between 1 and negative 1. Now, the second one, the amplitude is doubled. It has an amplitude of 2. Whatever number you see in front of sine, that is the amplitude. So it's going to alternate between 2 and negative 2. Now both graphs, they have the same period. It's just one is twice as large as the other. So that's the only difference. Now you need to be familiar with the general form of a sine wave. The general equation is y is equal to a sine bx plus c plus d. A represents the amplitude, B is used to calculate the period. Anytime you have a C value, there's going to be a phase shift, and D is associated with the vertical shift. So let's say if you want to calculate the period of a sine or cosine wave is 2 pi divided by B, and B is just the number in front of x. The vertical shift is D. If it shifts, let's say D is 3, it's going to shift 3 units up. If D is negative 2, it will shift 2 units down. To calculate the phase shift, set bx plus c equal to 0 and solve for x. So the phase shift is usually, it's negative c over b. But we'll talk about that later in the video. So how can we graph this particular function? Positive sine 2x. What would you do to graph it? So the first thing we need to realize is that the amplitude is 1. So it's going to vary between 1 and negative 1. Now we need to calculate the period. So how can we find the period? We know it's 2 pi over b. B is the number in front of x. So therefore, b is 2. So the period is pi. So you want to plot the period, and then you want to break it into 4 intervals. You should always do this if you want to graph, let's say, 1 full cycle. So what are the values of these other points that I have on a graph? What would you say? Half of pi is basically pi over 2. Half of pi over 2 is pi divided by 4. Whenever you want to find half of something, multiply by 1 over 2 or just multiply the denominator by 2. Now the first point is pi over 2 or 1 pi over 2. The next point is the same as 2 pi over 4. I meant to say the first point is 1 pi over 4, not 1 pi over 2. The next point is 2 pi over 4, which reduces to 1 pi over 2. The third point is 3 pi over 4. And the last one is 4 pi over 4, which reduces to pi. Once you get the first point, you can simply count it to find the rest. To get the third point, just multiply the first point by 3. So those are just some things to know. Now let's go ahead and graph it. So what we're going to do is we're going to plot points. We know sine starts at the center, and then it's going to go up, then it's going to go back to the center, then it's going to go down, and then back to the center. And then just connect it. Connect those 4 points. So that's how you can get a nice sine wave. Now what about this one? How can we graph sine x plus 1? What would you do in order to graph this function? So the first thing you need to realize is that it's been shifted up 1 unit. So the center line, which I'm going to call the midline, is now at 1. So what's the range of the graph? Now we know the amplitude is 1 as well. The number in front of sine is 1. So to find the upper limit, add these two values. 1 plus 1 is equal to 2. And to find the lower limit, subtract them. 1 minus 1 is 0. So it's going to vary between 0 and 1. Now the period is still 2 pi. The number in front of x is 1. So 2 pi over 1 is going to be 2 pi. And let's get the 4 points. Half of 2 pi is pi. Half of pi is pi over 2. To get this point, simply multiply pi over 2, the first point, by 3. Pi over 2 times 3 is just 3 pi over 2. So now let's go ahead and graph it. But before we do that, let's plot the 4 points. And we know that sine starts at the center. Positive sine is going to go up. Then it's going to go back to the middle. And then to the bottom. And then back to the middle. And then just draw a smooth sine wave. And that's how you graph it. By the way, if you need to find the domain and range of a sine function, for sine and cosine, the domain is going to be the same. It's negative infinity to infinity. There's no restrictions on the value of x. You can plug in anything. However, the y values have restrictions. The highest y value you can see on the graph is 2. The lowest y value is 0. So the range, which represents the y values, is from 0 to 2. Now let's move on to our next example. Let's try this one. Let's say that y is equal to 2 sine x minus 1. So feel free to pause the video and go ahead and graph it and identify the range of the function. So first, let's see what the period is. b is 1. The number in front of x is 1, so the period is 2 pi over b, or 2 pi over 1, which is just 2 pi. So let's plot our 4 points, which are going to be the same as the last example. The first one is going to be pi over 2, and then pi. The next one is 3 pi over 2, and the last one is 2 pi. Now, we have a vertical shift of -1. So therefore, let's draw a line at -1. Now, to find the upper limit of the graph, take the vertical shift and add the amplitude to it. The amplitude is 2. -1 plus 2 is 1. To find the lower limit, start with the vertical asymptote. I mean, not the vertical asymptote, but the vertical shift, which is -1, and subtract it by the amplitude. And this will give you the lower limit of the graph, which is -3. So it's going to oscillate between -3 and +1. Now let's plot the points. So once again, we have positive sign. It's going to start at the center. Then at pi over 2, it's going to go up to 1. And at pi, it's going to be back to the midline, which is at -1. And at 3 pi over 2, it's going to be down at -3. And at 2 pi, it's back to the middle. So that's one full cycle. Now, if you need to graph another cycle, simply extend the graph. So we can continue it. The next cycle will end at 4 pi because the period is 2 pi. Now, it's easier if you plot the points before graphing it. So at 5 pi over 2, it's going to be at the top. At 3 pi, it's back to the middle at -1. Then at 7 pi over 2, it's over here. And then at 8 pi over 2, which is 4 pi, it's back to the midline. And so that's how you can extend the graph if you need to. Now, what's the range for this particular function? So the lowest y value is -3, the highest is 1. So the range is -3 to 1. And it includes -3 and 1, so you need to use brackets. So now that you're getting the hang of this, why not try a different example? Go ahead and try this problem. Graph the function 3 cosine x plus 2. So what's the first thing we should do here? Since we don't have a 2 or 3 in front of x, we know the period is going to be 2 pi. The amplitude is 3, and the vertical shift is +2. So you can do it in any number of different ways. We can start with the vertical shift. So the graph is going to start 2 units above the x-axis. Now, to find the upper limit, or the highest y value, start with the vertical shift, which is 2, and then add the amplitude to it. 2 plus 3 is 5. To find the lower part, or the lowest y value, it's going to be 2 minus 3, which is -1. So it's going to vary between -1 and 5. Now let's plot the period. So one cycle is going to be 2 pi. The other 2 points are pi over 2 and 3 pi over 2, as you've seen before. Now we know that cosine, that is positive cosine, starts at the top, so it's going to start at 5. Then it's going to go, let me change the color. It's going to go back to the middle, and then all the way down to -1 when x is pi, and then back to the middle, and then to the top. So it's going to look like that. And if you want to, you can extend the graph. But if you just want to graph one cycle, which is usually the case, you can stop there if you want to. Now, what is the range for the function? The range is going to be -1 to 5. It's from the lowest y value to the highest. And that's it for this example. Go ahead and graph -5 sine x plus 3. So once again, we can see that the period is going to be 2 pi. There's no special number in front of x. So we're going to get the same typical 4 points. The vertical shift is at +3. So let's say 3 is at this point here. We don't have to be too specific, but you could if you want to. Now, to find the other points, we're going to add 5 to 3, and we're going to subtract 3 by 5. So 3 plus 5 is 8. 3 minus 5 is -2. So the graph is going to alternate between -2 to 8. So that's the range. It's from -2 to 8. Now let's plot the points. Positive and negative sign always start at the middle. But positive sign, we know, goes up. Negative sign goes down. So therefore, the next point is going to be at pi/2 with a y value of -2. At pi, it's going to be back at the midline with a y value 3. At 3 pi/2, it's going to be at 8. And at 2 pi, it's back to the center line. And so that's how we can graph this particular function. Now let's work on another problem. Let's say that y is equal to 2 sine pi x. So this time, the period is no longer 2 pi. There's no vertical shift, so d is 0. So 0 is going to be the center line. The amplitude is 2. So it's going to vary between 2 and -2. So that's going to be the range, from -2 to 2. But now let's calculate the period. So it's 2 pi over b, and b is the number in front of x. So b is pi. So 2 pi divided by pi is equal to 2. And then let's break this into 4 subintervals. Half of 2 is 1. Half of 1 is 1/2. And if we multiply 1/2 by 3, we're going to get 3/2, which is the average of 1 and 2. If you want to find this middle number, you can multiply this number by 3, or add 1 and 2 and then divide by 2. Just average those two numbers, and you'll get the number in between. So there's a lot of different ways in which you can use to find the missing points. Now let's go ahead and plot it. So we have positive sign, which starts at the center, and then it goes up, back to the middle, and then down to -2, and then back to the middle. And so that's how you can graph it. So hopefully at this point, you see a pattern in how to graph these particular functions. Now let's try this one. Let's say we have y is equal to -4 cosine pi over 4 times x plus 2. So let's calculate the period. The period is going to be 2 pi divided by b. In this case, b is pi over 4. Now to simplify this complex fraction, let's multiply the top and the bottom by 4. If we do that, we can see that on the bottom the 4's will cancel. On top, 2 pi times 4 is going to be 8 pi, and we still have a pi on the bottom. So the period is therefore equal to 8. Now for the vertical shift, we could see that it's positive 2. So let's add the amplitude, which is 4. So that's going to be the upper limit of the graph, that's 6. And if we subtract it by 4, we get the lower limit. So the range is going to be from -2 to 6. So the majority of the graph is going to be above the x-axis. So first, let's draw a midline, which is at positive 2. Then this graph is going to go all the way up to 6 and down towards -2. And 1 period is equal to 8. Half of 8 is 4. Half of 4 is 2. 2 times 3 is 6. Or if you average 4 and 8, 4 plus 8 is 12. Divided by 2, you get 6. So now that we have everything laid out, we can now plot the points. So we have a negative in front of the cosine, which means that it's going to start at the bottom. That's at -2. Then at 2, it's going to be back to the middle. And then at 4, it's going to be at its highest value with a y value of 6. And then back to the middle. And at 8, back where it started. So that's one full cycle. And I missed that point, so let's do that again. And so that's our cosine graph. It's been shifted up 2 units. It's reflected over the x-axis due to the negative sign. It's vertically stretched by a factor of 4, because that's the amplitude. And we have a period of 8. Now go ahead and try this example. Let's say that y is equal to 5 minus 3 sine 1/2 x. So what do you think we should do at this point? How should we graph this function? My lines are never straight. Well, that looks better. So let's calculate the period. So it's going to be 2 pi over b, and we can see b is 1/2. Dividing something by a half is the same as multiplying it by 2. So this is 2 pi times 2. So the period is 4 pi, and that does not look like a 4. Let's go ahead and do that again. Half of 4 pi is 2 pi. Half of 2 pi is pi. And in the middle, it's going to be 3 pi. Now, what is the vertical shift? Notice that this function is written in a strange order. If you want to, you can rewrite it like this. The vertical shift is positive 5. So let's say this is 5. Now to find the upper limit, let's start with the vertical shift and let's add the amplitude to it. 5 plus 3 is 8, and let's subtract it by the amplitude. 5 minus 3 is 2. So it's going to vary between 2 and 8. So that's the range. Now we have a negative in front of the sine function. So it's going to start at the center, but it's going to go down instead of going up. The next point is going to be at the middle, and then it's going to be at the top, and then back to the middle. So that's going to be the function. It's shifted up 5 units, reflected over the midline. It's been horizontally stretched by 2 units, vertically stretched by 3 units. Now let's move on to some examples that contain phase shifts. So let's say if we have the function 2 sine x minus pi. What should we do in this particular example? The first thing that you should do is set the inside part equal to 0. If we do that, we can see that x is equal to pi. So that's where the graph is going to start. Now once you get the first point where it starts, add 1 period to it. Since there's a 1 in front of x, we know the period is going to be 2 pi. So pi plus 2 pi is 3 pi. The vertical shift is 0. The amplitude is 2. So the range is going to be from -2 to 2. Now let's break this into 4 subintervals. The average of 1 pi and 3 pi is 2 pi. Now the average of 1 pi and 2 pi, if you add them up, you get 3 pi, but then you got to divide it by 2. So it's going to be 3 pi over 2. The average of 2 pi and 3 pi, 2 pi plus 3 pi is 5 pi, and then divided by 2. So it's 5 over 2 pi. Now we have positive sign, so it's going to start at the center, then it's going to go up, back to the center, down, and then back to the middle. So it's going to look like this. Let's do that one more time. And so that's it. Here's another example. -3 cosine 2x plus pi. So let's try this one. So let's find the phase shift first. Let's set 2x plus pi equal to 0. So we can move the pi to the other side. It's going to be -pi and then divide by 2. So it's going to start at -pi over 2. That's the phase shift. So it's been shifted left pi over 2 units. The amplitude is going to be 3. As you can see, my lines are just never straight. Now what about the period? The period is going to be 2 pi over b, and b, we can see is 2. So the period is equal to pi. So the phase shift is -pi over 2, and then add the period to it. -pi over 2 plus pi. Pi is the same as 2 pi over 2. This is equal to pi over 2. So the first cycle is going to be between -pi over 2 and pi over 2. The midpoint between these two is 0. And the midpoint between 0 and pi over 2 is pi over 4. And on the left side, we're going to have -pi over 4. So the amplitude is +3. So the range is going to be from -3 to 3. Since the vertical shift, it's not there, so the vertical shift is 0. So now we can make the points that we need to put on the graph. So cosine starts at the top, but negative cosine starts at the bottom. But we need to start at the phase shift, which is at -pi over 2. So that's the first point. Then it's going to be back to the middle, and then to the top, back to the middle, and then back to the bottom. So that's how you can graph this particular function. And so that's it. That's one cycle of the graph. If you need to continue it, simply add one period to pi over 2. And that's going to take it to 3 pi over 2. So let's say 3 pi over 2 is over here. And then you can break this into 4 intervals. And simply just extend the graph. Now my graph is not drawn to scale, so just keep that in mind. But at 3 pi over 2, it should be in the same position as it was here. Let's try one more example with a problem containing a phase shift. So let's say the function this time is -4 sine 1/2 x minus pi over 2 plus 5. So this problem has everything in it. So take a minute and work on this particular example. So let's begin by calculating the phase shift. Let's set the inside part equal to 0. So first we need to add pi over 2 to both sides. And to solve for x, simply multiply both sides by 2. 2 times 1/2 is 1. So you can cross out the 2's. So therefore x is equal to pi. Therefore, the graph has been shifted pi units to the right. Next, let's calculate the period. The period is going to be 2 pi over b, and the number in front of x, as we can see, it's 1/2. So this is going to be 4 pi. Remember, if you divide by a half, it's the same as multiplying by 2. Next, let's calculate the range. So the phase shift is 5, and we need to add the amplitude, which is 4. So the upper limit, it's going to be 9, and 5 minus 4 will give us the lower limit, which is 1. So the majority of the graph is going to be it's going to be above the x-axis. So let's begin by plotting the period. Actually, not the period, but the phase shift. So the graph is going to start at pi, and then if we add 1 period to it, pi plus 4 pi is 5 pi. So this is going to be 1 cycle. 1 cycle is basically the period. So the period is 4 pi, so that's the length of 1 cycle. It's 4 pi. Between 1 pi and 5 pi is 3 pi. Between 1 and 3, we have 2 pi. And between 3 and 5 is 4 pi. So the center line is going to be at 5. And the range is from 1 to 9. So now let's plot the points on the graph. So we have a negative in front of sine. Sine will always start at the center, but because there's a negative sign in front of it, it's going to go down before it goes up. I do need to make a correction. The phase shift is 1 pi. So the first point has to start at pi. Then it's going to go down, back to the middle, then to the top, and over here. So make sure you always start at the phase shift. So the graph looks like that. It's reflected over the midline. It's vertically stretched by a factor of 4. It's horizontally stretched by a factor of 2. And it's shifted by pi units to the right. And it's been shifted 5 units up. Now let's move on to cosecant. How can we graph the cosecant function? It's important to understand that cosecant is 1 divided by sine. And so if you can graph the sine function, you can graph the cosecant function. So the rules for cosecant is similar to the rules for the sine function. If the period for sine x is 2 pi, the period for the cosecant function will also be 2 pi. So it's going to have the same 4 points: pi, pi over 4, 3 pi over 4, and 2 pi. The amplitude of sine varies between 1 and -1. So sine starts at the center, it goes up, and then you know the routine. Now what I'm going to do is draw a dashed line instead of a solid line. Now I'm going to continue the graph though. Everywhere the sine function touches the x-axis or the midline, you need to draw a vertical asymptote. So I'm going to indicate that in blue. So now what should we do at this point? So at this point, we can graph the cosecant function. Cosecant is going to share the same y value as sine at the highest point and at the lowest point. So that's at 1 and -1. All you need to do is draw the reflection, and it's going to stay in the bounds of the vertical asymptotes. So the green part of the function, or the curve represented in green, that's what you have to draw on your test. The red line is just to help you to sketch the cosecant function. So that's how you can graph cosecant. Now, what are the domain and ranges for this function? Now, unlike sine, cosecant has restrictions. Cosecant could be anything except the vertical asymptotes. So for your domain, x is all real numbers except x cannot be pi, 2 pi, the next one's going to be 3 pi, then 4 pi, and so forth. On the left side, you have 0. If you continue it, it's going to be negative pi, 2 pi, 3 pi. So we need to write an equation. We could say x cannot be n pi, and we need to define what n is, where n is 0 plus or minus 1 plus or minus 2 plus or minus 3, and this just keeps on going to infinity. So that's how you can represent the range. It's by describing what values that x cannot be in this function. Now what about the range? We can represent it in interval notation. So what is the lowest y value? This curve goes all the way down to negative infinity. So therefore, the lowest y value is going to be negative infinity. At this point, the y value is negative 1. And there's nothing in between negative 1 to 1. Cosecant simply doesn't exist there. Now the function continues at a y value of 1 and goes all the way to infinity. So now we can write the range. So the range is going to be from the lowest y value. We need to use parentheses every time we're dealing with infinity. The lowest y value is negative infinity, and it stops at negative 1. Now, it includes negative 1, so we need to use a bracket. Union, it starts up again at positive 1 and continues all the way to infinity. So this is the range of this particular cosecant function. The only two values that you have to change are these two values, and you could change them here. Everything else is going to be the same for cosecant and even secant. But now let's graph the secant function. You can try this on your own if you want to. So remember, secant is 1 over cosine. So let's begin by graphing the cosine function first, and then we can graph secant. So we know the period is going to be 2 pi. And the range is negative 1 to 1, since the amplitude of cosine is 1. Cosine is going to start at the top, then it goes to the bottom, and then eventually back to the top. And let's continue it. So now, at this point, plot the vertical asymptotes. Everywhere the cosine function touches the x-axis or the midline, that's where you want to draw the vertical asymptote. So now let's graph it. So this side is going to look like that. And then we have this portion of the secant graph and this portion. If you want to stop at 2 pi, if you want to draw just one cycle, that's how it's going to look like. But if you wish to continue the graph, you can if you want to do that. So that's secant. It's very similar to cosecant, it's just been shifted. The range is going to be the same. It's going to be from negative infinity to negative 1, union 1 to positive infinity. And that's all there is to it. And the domain, though, it's going to be a little different. So this time, notice that the vertical asymptotes are at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. On the left side, the next one is going to be at negative 1 pi over 2. And it's going to repeat. Notice that the graph is symmetric about the y-axis. So it's going to be negative 1 pi over 2, negative 3 pi over 2, and so forth. So we can say x will not equal n pi over 2 and define what n is, where n is an odd number, such as plus or minus 1, plus or minus 3, plus or minus 5, and so forth. Let's try this one. This one's going to be a little harder than the last two examples. So let's say if we have 2 cosecant pi over 4 x and then plus 1. So what can we do if we have numbers inside and outside of the cosecant function? In a situation like this, graph it as if it were a sine. Imagine if you had 2 sine pi over 4x plus 1. Graph it the same way. So we can see that the vertical shift is 1. If we add 2 to it, the upper limit is 3. And if we take away 2, the lower limit is negative 1. So there is our midline. The graph is going to go up to 3 and down to negative 1. Now, there's no phase shift because there's no c value. Keep in mind, inside the parentheses is bx plus c. Since c is 0, the graph is going to start at an x value of 0. So we don't have to worry about the phase shift in this particular instance. However, we do need to calculate the period. It's 2 pi over b, and b, as you can see, it's pi over 4. So let's multiply the top and the bottom by 4. So 2 pi times 4 is 8 pi divided by pi. So the period is 8. So for this example, we're just going to draw only one cycle. So we have the points 2, 4, 6, and 8. So now we can plot it. Sine starts at the center, and because it's positive, it's going to go up, back to the center, down, and then back to the center. Now let's plot the vertical asymptote. So everywhere the sine function touches the midline, that's where we need to draw the vertical asymptote. So notice that the vertical asymptotes occur at 0, 4, and 8. So it's going to occur every 4 units, which is half of the period. So therefore we can find the domain. X could be anything except these numbers. So it can't be 4n, since it goes by 4. And we need to define what n is, where n is 0, plus or minus 1, plus or minus 2, and so forth. So you can represent the domain in that sense. So x can't be 4, negative 4, 8, 16, and so forth. That's the location of the vertical asymptote. And now we can graph cosecant. So simply draw it like this. Now, what is the range of this function? So notice that it's going to go down to negative infinity, and it's going to stop at negative 1. Then it starts up at 3, and then it goes up to positive infinity. So therefore, we can write the range like this. Negative infinity, that's a terrible infinity sign, let's do that again, to negative 1, so that includes negative 1, and then union, it includes 3 all the way to positive infinity. So that's the range of this particular function. Now let's work on one more example, but this one is going to be with secant. Try this one, -3 secant 3x minus pi plus 6. So here we have an example with a phase shift. So take a minute and work on this example. So let's begin with a phase shift. Let's set the inside equal to 0. And keep in mind secant is 1 over cosine. So we're going to graph it like a cosine function first. Solving for x, we can see that it's going to be pi over 3. Next, calculate the period. The period is 2 pi over b. In this case, b is the number in front of x. So 2 pi over 3. Now let's find a range. So starting with the vertical shift of 6, let's add the amplitude. 6 plus 3 is 9. And let's subtract 6 by the amplitude to get 3. So the majority of the graph is above the x-axis. So the center line is going to be at 6. And it's going to vary between 3 and 9. Now let's plot the phase shift. The phase shift is at pi over 3. And let's add one period to it. So 1 pi over 3 plus 2 pi over 3 is equal to 3 pi over 3, which is simply pi. Now half, midway between 1 pi over 3 and 3 pi over 3 is 2 pi over 3. Now what's between 1 pi over 3 and 2 pi over 3? What's halfway of that? So what you can do is you add them. 1 pi over 3 plus 2 pi over 3 is 3 pi over 3, which is pi, and then divide by 2. So that's pi over 2. Pi over 3 is 60 degrees, 2 pi over 3 is 120, pi over 2 is 90. 90 is between 60 and 120. Now between 2 pi over 3 and pi, what is this value here? So first, let's add 2 pi over 3 plus pi. 2 pi over 3 plus 3 pi over 3, which is pi, that's 5 pi over 3. Next, divide 5 pi over 3 by 2. To divide by 2, multiply by a half. So this is 5 pi over 6. Now you could see it in terms of 6. 1 pi over 3 is the same as 2 pi divided by 6. Pi over 2 is 3 pi over 6. And then it's going to keep increasing by 1 pi over 6. 4 pi over 6 can be reduced to 2 pi over 3. The next one is just 5 pi over 6. You can't reduce that. 6 pi over 6 can be reduced to pi. So if you have the first one, you can find the others if you get a common denominator, so to speak. So now let's go ahead and graph it, since we have everything that we need at this point. So keep in mind, we're graphing negative secant, which is associated with negative cosine. So we need to start with the phase shift, which is pi over 3. And negative cosine starts at the bottom. The bottom is going to be 3, and then it's going to go up to the middle, then to the top, and then back to the middle at 5 pi over 6, and then back to the bottom. So let's draw a graph with dashed lines. Next, let's draw the vertical asymptotes. So everywhere it touches the midline, that's where we're going to put the vertical asymptotes. And we're just going to draw only one cycle. So now let's graph the secant. So on this side, it's going to go this way. In the middle, it's going to look like that. And on the right side, that's how it's going to be. And so that's how you can graph just one cycle of this particular secant function. So now let's talk about the domain and range. So first, the range. The lowest y value is always going to be negative infinity. The 2 points of interest are 3 and 9. The first part of the secant function stops at 3. It includes 3. And then union, it starts back up at 9 and goes all the way up to infinity. Now for the domain, x can't be, in terms of 6, we have 5 pi over 6 and 3 pi over 6, which is pi over 2. Notice that the vertical asymptote differs by 2 pi over 6 or pi over 3. It's always going to differ by half of the period. So the next vertical asymptote should be at pi over 6. And then the next one to the left of pi over 6 is going to be pi over 6 minus half of 2 pi over 3, which is pi over 3, which is 2 pi over 6. So it's going to be at negative pi over 6, then negative 3 pi over 6, negative 5 pi over 6, and so forth. So we can say that x cannot be n pi over 6, where n doesn't include 0, but it includes plus or minus 1, 3, 5, and so forth, just the odd numbers. Now let's move on to a different example. How can we graph the tangent function? What's the generic graph of tangent? Tangent has 2 vertical asymptotes that you need to know. Well, actually there's more, but the first 2 asymptotes that you should know occur at pi over 2 and negative pi over 2. If you type in tangent pi over 2 in your calculator, make sure it's in radian mode, you'll see that you'll get a math error because it's a vertical asymptote. Now tangent and cotangent differ from sine and cosine in the period equation. For sine and cosine, the period is 2 pi over b. But for tangent and cotangent, the period is pi over b. B is still the number in front of x, so b is 1. The period for tangent is equal to the distance between the 2 vertical asymptotes. Notice that the period is pi over 1, so it's pi. If you subtract pi over 2 minus negative pi over 2, you're going to get pi. So now let's go ahead and graph it. Tangent of 0 is 0, and it's an increasing function, which looks like this. So that's a rough sketch of the tangent function. Now let's say if we wanted to draw another asymptote. The next one is going to be at 3 pi over 2. Tangent is going to pass through the middle, and it's going to form the same type of shape. On the left side, it does the same thing. And so that's the tangent graph. That's how you can draw it. Now the range for tangent will always be the same. It's negative infinity to infinity. As you can see, the curve is continuous going from the bottom to the top. So that's always going to be the range in this particular example. Now what about the domain? So all we need to do is remove the vertical asymptotes. X cannot be n pi over 2, where n is plus or minus 1, plus or minus 3, and plus or minus 5, and so forth. The next vertical asymptote is 3 pi over 2. And if you add pi, you'll get 5 pi over 2, and so forth. Now, if you need to plot points, at a 45-degree angle, at pi over 4, the y value is going to be 1. And at negative pi over 4, the y value is going to be, should be around negative 1, just in case if you need points. So for example, let's say if we wish to graph 2 cotangent x. Now we know tangent is an increasing function. That's positive tan. Negative tangent is a decreasing function. It looks like this. Now cotangent looks very similar to negative tan, and negative cotangent is similar to positive tangent. So positive cotan is a decreasing function. So let's go ahead and graph 2 cotangent x. Now the vertical asymptotes are not the same as they are in tangent. The vertical asymptotes are x equals 0, pi, and 2 pi. And on the left side, it's going to be negative pi and negative 2 pi. Keep in mind the period of tangent and cotangent. It's pi over b. So b is 1. So as you can see, the distance between vertical asymptotes is the period. In the case of secant and cosecant, the distance between vertical asymptotes is not 1 period, but it's half the period. So just keep in mind of that little difference. So now let's go ahead and draw the vertical asymptotes. So we also have one at 0, so just keep that in mind. Now let's plot points. Let's focus on the area between 0 and pi. I probably should have made a bigger graph, but we can still make this work. So between 0 and pi, it's going to be pi over 2. And between 0 and pi over 2, we have pi over 4. And between pi over 2 and pi, it's 3 pi over 2. Now, in the middle, at pi over 2, cotangent will be 0. At 3 pi over 2, typically it would normally be at a value of 1. But because we have a 2 in front, it's vertically stretched by 2 units. Now we need to keep in mind that cotangent is a decreasing function. So it should look something like that. So at pi over 4, it should be at 2. And at 3 pi over 4, negative 2. So this function is going to look something like this. At the x-axis, make sure that it curves. It becomes horizontal, then it's going to be vertical again. And then everything else is going to look similar. So that's how you can graph it by plotting points. Now let's work on a different example. Let's try 3 tangent x plus 1. So this time, I'm going to space it out more than the last example. So there's no phase shift, and the period is still pi. The standard vertical asymptote for tangent we know exists at pi over 2 and negative pi over 2. So there's a lot of space in between. So let's go ahead and plot the vertical asymptotes. Now notice that the graph has been shifted 1 unit up. So I'm going to draw my center line at 1. This is not a horizontal asymptote, by the way. So keep that in mind. So the middle point is 0. Between 0 and pi over 2, we're going to have pi over 4. And this side, negative pi over 4. So now let's plot points. At the middle, tangent is going to be at the middle. So it's going to have a y value of 1. Now tangent pi over 4 is usually 1, but it's been vertically stretched by 3. So instead of being 1 unit higher than the center line, which is at a y value of 2, it's going to be 3 units higher. So it's going to be at a y value of 4. And tangent is an increasing function. Now on the other side, a negative pi over 4 is going to be 3 units lower than 1. So 1 minus 3 is negative 2. Now let's go ahead and graph it. So this function should look something like that. Now let's work on another example. Let's say that y is equal to 2 cotangent, actually negative 2 cotangent, and then it's going to be 1/2 x minus pi plus 3. So what if we have a phase shift and a period and everything else? What do we need to do? In this case, you need to be careful. Now, if you're dealing with cotangent, remember the vertical asymptotes are 0, pi, 2 pi, and so forth. To find the first vertical asymptote, set the inside equal to 0 and solve for x. So if we move the pi to the other side, we can see that 1/2 x is equal to pi, and if we multiply both sides by 2, the 2 and the 1/2 will cancel. X is 2 pi. So that's the first vertical asymptote. Now to find the others, calculate the period. The period is pi over b, and b is 1/2 in this example, so the period is also 2 pi. So now when you graph it, you can start with the first vertical asymptote. To find the next one, you can add 2 pi to the right or 2 pi to the left. Let's get the one on the left. If we subtract it by 2 pi, we're going to get 0. If we subtract it by 2 pi again, we'll get negative 2 pi. So that's how you could find the vertical asymptotes whenever you have a phase shift with cotangent. Between 0 and 0 and 2 pi, it's going to be pi, and then we'll have, these are the points, pi over 2 and 3 pi over 2. Now the graph has been shifted 3 units up, and the amplitude is 2. So let's go up 2 units, which will take us to 5, and down 2 units, which will take us to 1. So at the center, at pi, it's going to be at the center line, which is 3. At 3 pi over 2, it's either going to be at 1 or 5, depending on if it's an increasing or decreasing function. Positive cotangent is a decreasing function. So negative cotangent is like positive tangent. It's an increasing function. So at 3 pi over 2, it's going to be at 5, and at pi over 2, it's going to be at 1. So this graph is going to look, I need to do this better. It's going to look something like this. So at 3, you want to curve the graph. You want to make it horizontal, so to speak, which it's not always easy to do, but that's what ideally what you want to do. So this graph should look something like this on this side. So the range, keep in mind, for tangent and cotangent is always going to be all real numbers, negative infinity to infinity. Y can be anything. And for the domain, simply remove the asymptotes. The asymptotes differ by 2 pi in this example. So we can say that x cannot equal n pi, where n is 0, plus or minus 2, plus or minus 4, plus or minus 6, and so forth. And so that's it for this example. So here's the last problem for today. Feel free to try it, and let's see if you remember how to apply everything you've learned in this chapter so far. So let's say that y is equal to negative 2 tangent 1/4 x minus pi plus 3. So the first thing that we can do is find the vertical asymptote. Now for cotan, we set the inside equal to 0 to find the first one. But for tangent, it's a little different. If you recall, the parent function of tangent doesn't have a vertical asymptote at 0. It has one at negative pi over 2 and pi over 2. So you can set the inside equal to any one of these, but I'm going to choose positive pi over 2. So if we add pi to both sides, 1 pi over 2 plus pi which is 1 pi over 2 plus 2 pi over 2. That's 3 pi over 2. And that's equal to 1/4 times x. So now I'm going to multiply both sides by 4. 4 times 1/4 is simply 1, so we get x. 4 times 3 is 12, divided by 2 is 6. So the first vertical asymptote is at 6 pi. Now the next one, we can use the period to find it. The period is going to be pi divided by b. And b is the number in front of x, so b is 1/4. So pi divided by 1/4 is the same as pi times 4, so it's 4 pi. So let's use the right side of the graph. Let's say this is 6 pi. We can add 4 pi or subtract 4 pi, but let's subtract 4 pi. So the next vertical asymptote is at 2 pi. And let's just focus on everything in between these two vertical asymptotes. So we need 3 points in between. Those points are 4 pi, 5 pi, and 3 pi. Now there's a vertical shift of 3. So let's plot that. And then the amplitude is 2. So 3 plus 2 is 5. 3 minus 2 is 1. Now we have negative tangent. We know that positive tangent is an increase in function. Negative tangent is a decrease in function. So what that means is that at 4 pi, it's going to be at the center line, which is 3. Since it's decreasing at 3 pi, it has to be above it. It has to be at 5. And at 5 pi, it's going to be at 1. So we can clearly see that it's decreasing. And so the graph is going to look like that. So now you know how to graph tangent and cotangent functions. So that is it for this video. Thanks for watching. By the way, if you want to find more videos on trigonometry, feel free to visit my channel and look for my trigonometry playlist. You should find some more videos on trig, graphing functions, verifying trig identities. So just take a look at those videos and they can help you on your next exam.